So next we want to focus on what makes a matrix equal to another matrix. So I think it's best just understood if we take a look at examples, then we can define it as such. So if we take a look at matrix F and matrix G right here, it clearly looks like they have the same number of elements because they both have 3 rows and 3 columns, so a total of 9 elements in each matrix. So they're definitely of the same size. If you take a look at the elements, they also have all of the same elements, also in the same positions, with one exception though. You can see that there's a 7 there and then a 0 there, so they're not matching there. So then that means that these matrices are not equal to each other. So we need the elements to be exactly the same in all of the same corresponding positions for the matrices to be equal. In the next example over here, it does turn out that these matrices are equal to each other because if you take a look at all of the corresponding elements in the same positions, they're all the same because 5/4 is the same as 1.25, square root of 16 is 4, and you can just take a look through all of these and they are all exactly the same value. The matrices are also the same size because they're 3 by 2 matrices. 3 rows, 2 columns, so therefore we can say that these matrices are equal to one another. These matrices, although they have all 1s, they are not equal to each other because they're of different dimensions or different sizes, so we need them to be exactly the same size to be equal to one another. And then this one right here, it looks like you've got some zeros that are kind of added in right there, but even with those added zeros, these matrices are not going to be equal to each other because we need them to be exactly the same size and have the same elements, and they definitely don't. So out of those 4 examples, really only that second one turned out to have equal matrices. So if we're to define what it means for matrices to be equal to each other, you could really probably boil it down to 2 characteristics. So 2 matrices are equal matrices when, number 1, the matrices have the same dimensions as one another. So if one's a 7 by 10 matrix, the other one needs to be 7 by 10, but not only that condition needs to hold, we also need to have the same elements within the 2 matrices, but not just in any place, they need to be in the same corresponding position, so same elements in all of the corresponding spots. And that will make matrices equal to one another. Okay? So overall, it's a pretty straightforward concept, but, to really boil it down to those characteristics, it takes looking at some examples to understand that. And then just a little bit more on equal matrices, some kind of problems that I want to take a look at down here at the bottom. So starting with this first one right here, it says to let P be that matrix and then Q be that matrix. If P equals Q, then find the product of X and Y. Okay, so think about what the problem is asking you to do right there. It's asking you to find the product of X and Y, and a product means the multiplication of X and Y. So of course, that means we're going to need to know what value X is and what value Y is so that we can actually find the product, or we can multiply them together. Now we do have some information to go off of because the matrix P is given and the matrix Q is given. We also know that we have this hypothetical statement saying that if P equals Q, so if the matrices were equal to each other, so if the matrices were equal to each other, okay, then we'd have this situation going on where P, which is 10, 6.5, 4, x minus 2y, 2x and negative 3, and then Q, which is 10, 6.5, 4, negative 4x, 5x minus 6, and negative 3. Okay, so hypothetically, if they're equal to each other. So you can see that, definitely parts of them are equal to each other because as I highlight with different colors right here, you can clearly see that they do have a lot of elements that they share in common, but kind of further, well, I guess we also have the 3's there, the negative 3's there. But then the other positions right there, they're not necessarily always going to be equal for every value of X and Y. So if we wanted these matrices to be equal to each other, then those 2 green corresponding positions would have to be equal, meaning that whatever X minus 2y is worth, then it needs to be the same value as negative 4x. Now, we can't solve that equation for unique values of X and Y because there's 2 variables but only 1 equation. So we're going to kind of need to figure out some more information to come up with some sort of a unique answer here. And then we can also see that 2x and 5x minus 6 are in corresponding spots. So we also need it so that 2x needs to be the same as 5x minus 6. Now from that equation, we can solve and find a unique value for x. So if I subtract, say, 5x from both sides, then we would have negative 3x equals negative 6, and then we can divide by negative 3, solve for x, which gives us x has to be positive 2. And then if x has to be positive 2, then we can use that value and plug it in that equation up there, and then we should be able to find a value for y. So now if we take that green equation and we plug in the 2 for x, now we have 2 minus 2y equals negative 4 times 2. So that means then that 2 minus 2y needs to equal negative 8. And then I'm going to subtract 2, meaning that negative 2y equals negative 10. And then we can divide by negative 2, which gives you a value of 5 for y. And so based on that, then we should be able to answer the question that was asked of us up here, which was to find the product of x and y. So since x was 2 and y was 5, then the product would be to multiply them, which then gives us a final result there of 10.